So welcome back to paper 2, part 2, and we are starting now at question 9. You're going to need some tracing paper or some greaseproof paper. I've got some greaseproof paper here out of the kitchen, and the first thing we need to do is read the question. It's shaping the line, and here is our diagonal line y equals x. Remember, all coordinates on a line y equals x has x coordinate that equals the y coordinate, or indeed the y coordinate equals the x coordinate. If I pick 2 points on the line and I label them A and B, I can trace those 2 points, A and B. I can draw in the mirror line if I want to. Then I go to the image and I trace my image. I then take my tracing paper or greaseproof paper, I flip it over, flipped image for the reflection, place A back onto A. I use my pen to hold that in place. It's a little fiddly, as you just saw there. Put my pen into place to hold it. Move B onto B, and then you can just rub slowly a little bit over, and you get the key points for the reflection, and you can draw it in, and that is complete. We now come to part B. Describe fully the single transformation that maps B onto C. That is alphabetically ordered, you'll notice. This is a translation. The image has moved. So if I write translate, or indeed translation, I'll get 1 mark. But then I need to give the vector by which the image has moved. The top number is the change in x. The bottom number is the change in y. And if I pick this corner point here and then refer it to this corner point here, you can see that it's moved 1, 2, 3, 4 times to the right. The x coordinate value has gone from -2 to +2, and that indeed is a +4. It has then moved down 1. It's moved from a value of 3 for y to a value of 2 for y, and that is a -1. That will pick up the 2 marks. Moving on to question 10, we have to find the total surface area of a triangular prism. This shape has 5 sides to it. It's got a triangle here, it's got the identical triangle at the other end, it has a base rectangle, a side rectangle, and a sloping rectangle. The area of the triangle is given as a half times the base, which is 15, multiplied by the height, which is 8. And there are 2 of those. The calculator will generate that area very quickly, and that generates 60 centimeters squared. There are 2 of them, so I write another 60 centimeters squared. It is likely that you will pick up a mark for showing one of the areas on this shape. We're now going to do the actual base rectangle, and that is 15 by 10, which generates 150 centimeters squared. We're then going to do the side rectangle, which is 8 here by this distance here, this dimension here, which is 10, which generates 80 centimeters squared. And then the sloping rectangle is 17 by 10. The second mark will be given when you start to show all 5 areas being added together. On your calculator, you can now add 60 to 60 to 150 to 80 to 170. Always record your answer and then check it again. That will get you 3 marks. So second mark for adding the correct 5 areas together, third mark for 520, and the fourth mark is for stating the correct units, centimeters squared. Question 11. This is a very tricky question, this, because you need to know what the square root of x minus y over xy is. And a lot of students may or may not forget to do that. So that's the key there. I would move my square to be square root straight away. On the mark scheme that I've done already for this, I've suggested that if you forget to do the square root, you may pick up marks for seeing the following. So there may be in the mark scheme an allowance for seeing this number, or indeed this number. So I would say there might be an allowance for 1 mark for either of those. And there may be an allowance for seeing this number times 10 to the minus 9. So that's where you may pick up some special condition marks in this question. What I'm going to do now is actually write it out in full and do it pretty much in one step. I'm going to use a bracket here to help the calculator. You don't actually need a bracket, I don't believe, but I'm going to do it anyway. The function on the top is a subtract, the function on the bottom is a times. And of course we're square root and all of that. So now it's time to enter that into the calculator. So for doing that, I press my square root and my fraction key. I then type in 8.5 times 10 to the any power, and of course it's a power of 9. Remember then to navigate out to complete the power. I'm closing my bracket there, subtract 4 times 10 to the any power. I need a power of 8 this time, navigate out, close bracket. Typing in exactly the same two numbers that I've just typed in, navigate out, close bracket, times this time 4 times 10 to the any power 8, navigate out, close my bracket, and the second mark in the exam would be for writing that entire number, of course, times to 10 to the minus 5. So there's the second mark I would suggest in the paper there. So 1 mark for showing this, or indeed any of these numbers here, and the second mark for seeing this. Now if you've gone straight to that because you've gone from there to there like I have, you'll have 2 marks in the exam. We've got to write this to 2 significant figures and in standard form. So 1 to rounding number 4.8 or 4.9, you can clearly see it's 4.9 because the rounding number, times 10 to the minus 5, and that's the third mark in that question. Question 12. You're going to get a mark if you multiply by 4 and multiply by 4, so you'll expand the bracket there. Lots of students will forget to do the second part of that expansion, so 2 arrows there to remind myself is a good clue that there are 2 multiplications by 4 there to remind yourself. You'll get 1 mark for the site here. You may have to write it and form the equation, so don't forget to copy that down as well, but that is pretty much 1 mark there. The lower amount of x is 3x, so we're going to take away 3x from both sides so that we mathematically remove it here, and that gives you 5x minus 4 equals, and don't forget that's a minus 19. It's likely you'll get the second mark at that stage. Now, taking care with this, this is a minus 19, this was a minus 4, so it will now be a plus 4. Your calculator will help you with this, no problem at all. Telling the calculator that we're dealing with a minus 19 first, and then adding on 4 gives you the minus 15. A times by 5 becomes a divide by 5, and again remember we have a minus 15 in play. So, fraction key, tell the calculator again it's a negative 15 you're working with, put in the 5, and it gives you an answer of x equals minus 3, and that's where the third mark would be for the minus 3. In question 12b, you've got to divide by 5 here, so effectively all of that is being divided by 5. So your first step is to show it as a times by 5, and you'll pick up 1 mark there if you move the divide by 5 to be a times by 5. Now I know you all know that's 150, but we're in a calculator exam. Check everything on a calculator just to make sure you don't make a silly mistake. Now I do it every day. Every day in class I make a silly mistake, and we talk about that, and it's just making sure in the calculator we're checking everything. A plus 4 becomes a minus 4, and again just keep checking these things on the calculator, checking what you've written, checking it all, and that's 146. So y is 146. Now lots of students will look at that and think it's completely wrong. How can y be 146? Well, it can be. And it's been a long time since the calculator exam had a question like this. Everybody always thinks y can only be 1 or 2 or 3 or minus 4. But it can indeed be large numbers as well, so watch out for that. If it feels right and you've checked the functions, go with your answer. Question 13 part A. We have the number 7np to the power of 4 3 times multiplying by itself. And that is what is being stated here with this power of 3. This number is multiplying by itself and by itself again. If we now use the associative law, we can reorder the question. And we get 7 times 7 times 7, 3 n's multiplying together, p to the power of 4 times p to the power of 4 times p to the power of 4. 7 times 7 times 7 on my calculator, apologies, 7 times 7 times 7 on my calculator generates 343. N times n times n I can see is n to the power of 3. 4p's multiplying here, another 4p's multiplying here, and another 4p's multiplying here. It gives you p to the 12. And there's the final answer. It's only worth 1 mark, and hopefully you'll get that right. First law of indices here, we've got 5m's multiplying together and 3m's multiplying together, and hopefully you can see the first law of indices in play there. There are 8m's multiplying together. You add the powers together for first law of indices. Second law of indices now in play. There are 6p's multiplying together and 2p's multiplying together. P times P goes into P times P once, leaving you with 4p's that are still multiplying together. And that, of course, is the second law of indices, where we subtract the dividing power from the leading power there in the numerator position. Question 14 now. We've got similar triangles, which means there's a scale factor in play. And I always like to see what's happening by showing a multiplication by scale factor. So this is being multiplied by the scale factor and it's generating 10. If I write out that statement, I can start to see what's happening. And now a times by 6 becomes a divide by 6, and I've got 1 mark in the exam for stating the scale factor. 10 over 6 does simplify down, and it simplifies down to 5 over 3. So the scale factor is 5 over 3. Do not be tempted into using the decimal here. That is not 1.6. It's actually 1.6 recurring, and if you use 1.6 and drop that recurring dot, you'll lose marks left, right and centre. So keep it as a fraction. We're now being told to generate the length BC, which is this here, which means 12 is being multiplied by the scale factor, and it will generate there. So 12 times by the scale factor, which I now know is 5 over 3. 12 times by 5 over 3, and that generates a length of 20. That, of course, is 20 centimetres, and I place that there and commit that answer. I've now got to work out the length P to R here. So if I just call that x for a second, I know that x times by the scale factor will generate, in fact, that number there, 18. So x equals a times by 5 over 3, 5/3, becomes a divide by 5 over 3, 5/3. Your calculator again will take you through the motions here. 5 over 3, so divide by 5 over 3 equals 10.8. Question 15 is another calculator question, and what we're checking here is the use of the calculator. So square root, fraction key, tan. Now, the calculator opens up a bracket. We put the angle of interest in, 60 degrees. We must remember to close that bracket there and then add the 1. Tan 60, close bracket, and minus 1. Press equals, and we get 1.931851653. Remember to write your full calculator display. Now, if you forget to put in the square root, it is likely that there'll be 1 mark for the sight of this number here. So if you've got that number there, 3.73, I'm just going to write it here to remind myself. If you've got that number there, it is likely you will have 1 of the 2 marks in that question. We're now going to round this to 2 decimal places. 1, 2, rounding number. So 1.93, because the round number was 1. If you've rounded this correctly and have wrote 3.73, you will pick up that mark. There is an FT mark there where you're allowed to use a question that has been incorrect. So if you've committed that, you've got 1 mark, I would suggest. And then if you've rounded it correctly, you do get that mark there. Question 16, this is a percentage it is a percentage profit question. I was going to say a percentage change question, but it's a percentage profit question. So your number one task is to work out the profit. So if we take the sale price and remove the original purchase price, you get 4,500 profit. Remember to do that on your calculator. Now, to find percentage profit, it's the change or the difference over the original multiplied by 100. Now, the times by 100 simply takes a decimal to a percentage. The change in this question is 4,500. That's the profit, of course. The original amount we bought the house for is here, and that's where students will drop a mark. If you've put this number in here, you will not pick up any more marks. So 1 mark for the profit, and if you multiply that by 100, you've now picked up a second mark. Now, some mark schemes allow just this bit here with the change over the original, and some mark schemes are stating that you need to show the 100. So I'm going to stick with showing the 100 as well. Using your calculator, profit over the original amount times by 100 to turn it into a percentage, and you get a nice straightforward answer of 3%. We're now going to invest that money for 2 years at the interest rate of 4.25%. Your first job is to find the multiplier, and your calculator will do this for you. If you type in 100, press your shift and open bracket key on the Casio calculator to get your percentage. Add on 4.25, again shift and open bracket key to add on the 4.25%. Pressing your SD button, and that generates the multiplier for you. So the amount of the investment multiplied by the multiplier, and for 2 years, so it's a repeated multiplication. If you have actually wrote out each year, which is a valid way of doing this question as well, you will also get the first mark. So I need to see all of that or all of that for the first mark. So let's invest this money. Now, you won't get the mark for seeing that answer. We are dealing with money, and you're going to have to round it to 2 decimal places. I'm sorry that I didn't leave enough space. I will change that for next year. And it's not 56 pence, it's 57 pence. Now I must see all of that correct, 2 decimal places correctly rounded for the second mark on that question. So we're now on to question 17, and we have to find the area of a trapezium. The formula for the area of a trapezium is a half of the parallel sides added together, multiplied by the perpendicular height. This is a bit of a sneaky question here, because we've got to turn the exam paper sideways there to find that our parallel side A is there, our parallel side B is there, and our perpendicular height is here, of course, running between the 2 parallels. If I now put that into the formula, I get a half 4 plus 12 multiplied by the perpendicular height, which is 10. Your calculator will help you with that calculation. So a half of 4 plus 12, but then don't forget to multiply that by the perpendicular height, and that generates 80. So the area is 80. Now there is another way of doing this. If you draw a line here, you create a rectangle which generates 40 centimeters squared. 4 times 10 is 40. You also then create a triangle here which has a base of 10 and a height of 8. Because if that bit's 4 and the whole length there is 12, the remaining part is 8. And don't forget, the area of a triangle is a half times the base times the height, and that will generate also 40 centimeters squared. If you now add those 2 together, you get the 80, and you would pick up all the marks. So even if you don't use the formula, if you use a rectangle and a triangle correctly, you will get all the marks on that question. Our final question is question 18, and it's a probability question. There are 5 red pens and 2 green pens, so there are obviously 7 pens in total. Reading it carefully, we can see that we take a pen at random, but then we give that to our friend, so it is removed from the situation. Gary then takes another random pen. So the first probability is either red or green. There are 5 red out of 7 pens and 2 green out of 7 pens. You'll pick up 1 mark if you can show both of them. The first probability for a red pen and the first probability for a green pen, that is worth 1 mark. Taking another red pen, taking a green pen, taking a red pen and taking another green pen. All these probabilities are actually going to be over 6. And if you've left them over 7, I'm afraid there are no more marks in this question. And that's because we removed the pen from the probability. So if we take a red pen, there'll only be 4 left. If we take a green pen, there'd only be 1 left. It's always worth doing the repeated situation there to see what happens. That'll put 2 green pens there because that has to still total to 1. That'll put 5 over 6 there because that still has to total to 1. And you've now got 2 marks in the exam. If we multiply out every single root, there is a chance you will pick up another mark. This is known as the AND function, and you need to multiply the probabilities together for each root through the tree diagram. Now I always say that use the calculator in the exam, if you're in the calculator exam. I do. But in this occasion, just multiply the denominators to generate 42. And that's because that's a repeated multiplication. It speeds you up slightly. 5 4s are 20, 5 2s are 10, 2 5s are 10, and 2 1s are 2. Again, use your calculator, check them, and add those numbers together, you should get 42. Now, there's a chance you've picked up another mark at that point. However, the mark scheme may need you to do a little bit more for the next mark. Work out the probability that both pens are the same colour. Well, that's red, red, and green, green. Red, red has that probability, and green, green has that probability. The mark scheme may need you to show both of those being added together to get the third mark. If you add them together, you do have a calculator. So 20 over 42 plus 2 over 42, and that gives you 11 over 21. Can I just point out that 22 over 42 would also be allowed for that final mark. So I'm suggesting 1 mark for sight of these, 1 mark for all 4 of them correct. 1 mark maybe for showing these 2 multiplied out. If you've done them as well, you don't lose any marks, but it might be for the addition of red, red and green, green. And then of course the final mark is there. Thank you for watching.